Alright, so in this example, we're going to look at how to create this dynamic, responsive, and parametric seating using a rail curve, which is going to basically dictate its length and curvature of the path, right? It could be straight, it could be kind of serpentine, or just a simple kind of arch or curve. We can see that if I turn the control points, I have that ability to, like I said, give it a different kind of overall shape and length. And then I have these two rectangles, which are going to represent the profile or the cross-section curves of our seat. So basically, they're going to represent both the start and the end of that curve. And so in order to start this, we want to first reference our curve. All right, so there's our curve. And in order to start to get these things oriented, we need to use both their start and end points. So there's that. So here's the critical part to understand with this is that we want to make sure that these, again, instead of them just sitting on this kind of top view down or the XY plane, we want them to actually orientate to be on the ZY plane, right? So they're going to be facing out like that. So there are some kind of steps to make sure that that hasn't happened. And I'm going to quickly just show you what happens if you don't kind of take some of these extra steps. If I just go to curve closest point, so I'm just going to first start looking at that point. Gives me my parameters where I can create a perpendicular frame, which logistically seems like it makes sense, right? This is the plane that I want them to orientate. But notice where the red or the x-axis and the green or the y-axis are orientated as it stands right now, right? So that's going up, that's going to the right. Let's see what happens if I turn these control points and start to mess with my rail curve. I'm going to move it there. Now the red's going to the right, green's going down when it's like that. If I move it here, now the green's going up and the red's going to left. So it's always kind of shifting directions, and that's basically going to shift where this is orientated to, because it's all based off of this plane, and that's going to create some major issues if we start to manipulate it. So what we actually want to do, instead of using this perpendicular frame, we're going to create a horizontal frame. And the reason for that is you would think that, well, isn't that going to change too if I start to move it? What's nice about it is notice that the red or the green is going to be perpendicular to our path, and the red is always pointing tangent with that path. So I'm going to turn these points on and start to move it, and you'll see that, again, green's perpendicular, red's tangent. Oops. I move it to the other side, again, green's perpendicular, red's tangent. So that's always going to stay consistent, which means that regardless of how we change our rail curve, our cross-section curves or these profile curves are always going to stay orientated as well. So in order to actually get this to become a perpendicular frame, we need to first deconstruct it and construct a new one based off of these parameters. So it's still going to give us what the perpendicular frame does, but this again is going to stay consistent. So I'll go to vector and deconstruct our frame. Before I go any further, I'll just show you. So basically we want the green to stay in the green, so y is always going to be y, but in order to get this to be perpendicular, I need the red axis to now be pointing up. So the red, or this x-axis, is now going to serve as our z-axis. Or in this case, the z is actually going to act as the x. So I'm going to now construct a plane. The origin's going to be the same. Like I said, the y we want to keep the same, so y goes into the y, but this frame's z-axis is going to be the new x. So I'll plug that into there. now we can see it's orientated perpendicular. And again, I'll show you what happens. Kind of contrary to the last one, if I move these around, again, green is always staying in that direction and red is always pointing up, which is, again, key to ensure that if I start to manipulate this, no matter how I do it, those always stay the same. So I have that, and now I want to, again, begin to orientate this geometry to that. So I'll go ahead and I'll keep that on, just again, kind of help you understand this. So now I want to orientate again this one to that. So now let's just give myself a little more room from the top. I want to first reference this curve. And you'll see that I have a point also in Rhino here to help me, again, orientate it correctly. So basically I want this corner of my rectangle to be at that point, right? It always likes to match points with points, not curves with points. So that's why you do want to kind of include this. And obviously if you move this point around, then it'll shift accordingly. So what I'm going to do now is also reference this point. And again, if I just use the XY plane as this origin to kind of help me orientate, I'll notice that these axes aren't exactly going to match up correctly. On these cross section, the Y or the green is going up and the red is going to the right. For this one, the red is going up and the green is going to the left. And you would think, why don't I just orientate this that way? It's better to make sure the thing that you're going to manipulate the most, so this rail curve, stays consistent, and you try to get this to match that versus the opposite. So instead of just creating an XY plane, I'm again going to construct a plane. So that's that. Right, so now for this new plane, I want the x-axis to go in this direction, so that's actually going to be the z, or sorry, not the z, the y. So I'll use unit y. And then I want the y-axis to go in the x direction, but in the negative. So if I just hit x, you'll see that the green is going this direction with the rectangle versus for this one it's going to the opposite direction or in the negative direction. So for this unit x one that I plugged into the y here, I'm going to go ahead and go to expression and say negative x. So that's now a negative value. Now you can see that that's going in that direction. Okay, so I've gotten them to more or less match this way. Now I have to actually get them to physically orientate themselves. So I'll go ahead and turn all of this off. And now I'm going to use the Orient component here. And so it's asking for the geometry that you want to do that for, what that plane is for that geometry. So that's the one we just created. And now it's asking for the target plane, so the one that's over here, or this one. So now I do that, and now I have it nice and orientated there. So what's good about this too is that this is just for obviously the start, but we can just copy and paste this and just move a couple of these other ones around. So instead of the start going into that one or into this one, I'm going to use the end. Okay. Then I want to also use this other geometry. So this is my new curve, and this is the point. And now again, it's all orientated together. I'm going to just go ahead and turn, or no, I'm going to keep those ones on. I'll keep these turned off. So I just have, again, these guys. I'll turn this one off. And now what we can do is use the rail or the sweep component, so sweep 1, to make this actually a solid object. So it's asking for the rail curve, so that's this one. It's asking for the cross-section curve, so I'm going to drag that one into there, and then shift to drag that one also into there. And again, it's not really anything special right now. Obviously, I can, again, turn these control points on and start to shift it, and everything will respond to it that way. But again, it's just a simple rectangle. There's really no need to use the sweep one if they're going to be the same. But this is again where you can have a little more fun with it, where I can turn the control points on for both of these. And in this case, maybe this point starts to shift over, so it gets kind of like a sharp point, so you can see that's that. And maybe for this one, I just move the point up, so it's kind of more like this. So now again, it's all responding to that now, which gets kind of interesting. And again, I'll manipulate this to get, again, kind of a little better result. I want to maybe make it a little bit longer in some cases. Okay, so maybe it's starting to look something more like that, some kind of S orientation. And again, it's all just coming from this single curve. But let's start to do a little bit more with it. Instead of it just being a solid volume, something that's commonly done with this is that they start to get ribbed with different wood frames. So we can start to do that as well. So let's turn this off. So I'm going to use the contour component. You'll see that there's 4 that come up. There's the standard contour that's based off of a direction, but there's also one based off of a plane. So we actually want to use the plane for these. So again, it's asking for the shape that we want to contour. And in order to, again, kind of make sure that these are going to get sliced perpendicular every time, we want to make sure that we're using frames instead of that are perpendicular at all times. So in this case, I actually do want to go to curve and use this perpendicular frame. So it's asking for curves, and it's going to create these perpendicular frames. And it's not, doesn't really matter the orientation of these, they're all going to stay consistent. I can drag in something closer to like 50, right? So it can be pretty dense starting out. So I'm going to plug that into there, turn this off, and then I don't really need to offset them, but I do want to create a 0 distance so that basically these contours happen at every single one of those planes. Now I can turn this off, right? So now I've started that process. And again, to get the frame, what I want to do is start to offset these. So I'm going to use the offset component, use that curve. I can just go ahead and flatten this. I don't need them to all be separate. It's asking for a distance, so I'm going to do 0.25, so 4 inches, sorry, 3 inches, since it is in feet. I'll see that if I do that, it just starts to put them in all sorts of different directions. So sometimes it goes to the outside, sometimes it goes to the inside. I'll show you how to correct that, but I do want to make sure that it is in the negative so that they all go inside. But this is what also helps, is asking for a plane. And so we can use these same perpendicular frames to do that. So now they're all on the inside. It's nice and clean that way. We can always adjust how much we want it to offset. Okay. So now we can take these 2 curves and create a ruled surface to make an actual surface on the inside. Oops, we don't want to, I don't know why it keeps grafting these, but I'm just going to flatten it. So now I've got a solid surface. And now I can take that surface and extrude. And again, I can't just give it a generic direction because they're all have their own unique directions. But again, I've got these perpendicular frames, and basically what I want to use is their Z direction. So I'm going to look at these, I'm going to deconstruct them, and use the Z direction. You can see it's going to, again, it's going to do it in the right direction, but they're all generic, like a 1 foot extrusion distance. So instead of doing that, I'll stick within this vector, but adjust it with the amplitude. So it's going to use that direction, but I get to dictate how far it extrudes it. So let's start with something like 0.0825 to represent 1 inch. Right, so that's what it looks like if those are all an inch thick. I can add more to these, so it's a little more dense. So that's looking cool. So obviously with all these frames, if you're really committed to looking at how you'd fabricate this, we need to also add some type of cross beam that's going to connect all these together. So maybe you just want to use something like PVC pipe. It's a little easy to bend. Obviously you can use metal too. It's going to be a little more costly to get it to match these curves. But what we can do is basically figure out the points at each one of these corners. So I'm going to go back a little bit here. And I'm going to look at the ones that I've contoured as well as the ones that I've offset. So I want these pipes to go at these corners in the middle. So what I want to do is tween these two curves. Let's go ahead and just flatten it that way. So that's going to there, right? So now I've got this middle curve. And from here, I just want to use the more or less the corners. So if I go to curve, divide the curve, and make sure that I use or have the kinks on, or basically the corners, I can turn that on and use 0 as the number, so it only is going to focus on those main points, right? So you can start to see how that works. I don't know why some areas they disappeared on me, like the bottom corner. It's a little odd. You'd think that that's definitely a kink in this. But again, it can require a little more finesse to get it to happen, but for now it should be okay. So from these points, we're going to create, again, a pipe. So I'm going to go to sets, I'm going to flip these points so that it doesn't just recreate this curve, but it actually connects them this way. Then I can use the curve, interpolated curve. Right, so there's those ones. And now I can use the surface pipe. Now I'm going to go ahead and flatten these, drag that into there. I don't need them to be obviously that thick. Let's use something like, again, a 1 inch thick. So now I have my pipe. So I probably want to make these a little bit thicker. So let's offset them a little bit more. Again, there's some kind of weird things, but I can just manually get rid of those at some point once I bake it. It's easier that way than trying to actually organize the data. So I've got my pipes. Again, I've got my extruded surface here. So let's go ahead and just bake these two parts. Let's maybe make them a little bit thicker, so I'm going to extrude them a little bit more. Doesn't seem like it extruded them that much more. Let's try 0.25. Maybe not that much though. And that looks nice and dense. Let's make it, no, let's just get right at like 0.25. Perfect. Okay, so now I think I'm ready to bake these. I think there's enough of them. Let's go ahead and bake it that way. And turn it off. Right, so there you go. Let's turn these off as well. And again, like I said, I'm just going to manually get rid of those unnecessary pipes. So if I look at it ghosted, we can start to see that we've got those support beams in it now.